Now that we've seen the graph of the tangent, we can look at the graph of the cotangent of x. Since the cotangent of x is the reciprocal of the tangent of x, and we knew the tangent of x was sine over cosine, we can say that the cotangent of x would be the reciprocal, so cosine x over sine x. Again, I've highlighted some key points here on the graphs of the sine and the cosine to help us determine values for the cotangent of x. Let's start when x equals 0. When x equals 0, we have a point here for the sine of x being 0 and the cosine of x being 1. So the cosine of 0 over the sine of 0 would be 1 over 0, or undefined, which means that we have an asymptote along the y-axis. So I've put in that asymptote. Now if we move over to 45 degrees, we can see that the cosine of x and the sine of x are equal to each other because they cross at 45 degrees at that value of 1 over the square root of 2, which tells us that I need a point at 45, 1. So there's a point there at 45, 1. Now, at 90 degrees, we have a sine value of 1 and a cosine value of 0. So cosine 90 over sine 90 gives me a 0 over 1, or 0. So at 90 degrees, our cotangent value is 0. Let's put that one in as well. At 135 degrees, in the second quadrant, we can see that our reference angle would be 45 degrees. So the magnitude of our opposite and adjacent sides would both be equal to each other in a 45, 45, 90 triangle. So if we look at the cosine of 135 versus the sine of 135, cosine of 135 is negative in the second quadrant, so negative 1 over the square root of 2. And the sine of 135 is positive. Our opposite side is a positive value, 1 over the square root of 2. And their ratio gives me a ratio of negative 1. So at 135, I need a point at 135, negative 1, right here. At 180 degrees, the cosine is negative 1, and the sine of 180 degrees is 0. We have no vertical side to our reference triangle at 180 degrees. So when I try to create that ratio, negative 1 divided by 0, I get undefined again, which gives me another asymptote there at 180 degrees. So let's put that asymptote in. So now I have asymptotes at 0 and 180 degrees as opposed to the asymptotes at negative 90 and 90 for the tangent graph. So let's take a look at what the cotangent graph would look like. If I bring that up, we see very similar but different behavior compared to the tangent graph. I'm going to clear the sine graph and the cosine graph. And we see that the cotangent repeats as well, but its asymptotes start at 0, then 180 degrees, and then 360 degrees. And instead of rising, it falls as we move from left to right.